Hello and welcome to the first of a three-part series on the book Why Evolution is True by Jerry Coyne. In this installment, we will explore Chapter 2. This is Tiktaalik. It was one of the first fish to evolve limbs that were capable of maneuvering its entire mass. This is one of the many missing links in the fossil record that is no longer missing. The discovery of fossils is the key point of Chapter 2. Fossils provide physical evidence which has been interpreted by scientists as proof of evolution. Jerry Coyne, the author of this book, intended the book to be support for evolution for the lay individual. The purpose of this video will be the same. Let us journey back in time to various geological eras where we will find physical evidence in the fossil record for evolution. Evolution being defined as the variation in allele frequency over time. When the Earth was formed, there was no life. Sometime around the Cambrian, life in its simplest form appeared. Throughout the rest of Earth's history, we see the diversification of life. The increase in diversity is a result of evolution. As alleles vary, they tend to change in ways that will increase or decrease their complexity. This is the differential expression of a shared ancestral trait between species. This is how species evolve from less complex forms into more complex ones. What exactly is written in the rock? From the bottom to the top, or if you prefer, from the inside out, the Earth is composed of several layers. The deep mantle is the first. The second is the asthenosphere, and the third, outer layer, is the lithosphere. The Earth is not a fully solid piece of matter. The inner core is completely molten, and the layer immediately above the deep mantle is the asthenosphere, which is also molten. The uppermost layer of rock, the solid layer, is the layer of interest, though. In this layer resides the rich history of life's diversification. This history is layered in the sedimentary rock that covers the Earth's lithosphere. To answer the original question, the history of life on Earth is what is written in the rock. How the message is written. This is the story of fossilization. There are certain things that need to happen for an organism to become a fossil. 1. Once an organism has died, it is necessary for it to quickly find its way to the bottom of a body of water. This prevents rapid decay and harassment by predators. 2. The organism is then quickly covered by sediment, which continues to cover the organism until it is discovered. Over time, dissolved minerals replace the volume once occupied by the organism. After significant time has elapsed, what results is a casting of the organism's likeness. 3. After many millions of years, the fossils are discovered and their hidden information deciphered. Nature of fossils. Because fossils are formed at random and they are discovered at random, it is a wonder that the fossil record is as complete as it is. The limitations of fossils. To become a fossil requires the proximity to water, something that does not exist everywhere. Also, it is estimated that only 0.1% of species which have ever lived have been discovered in the fossil record. So the fossil record is pretty incomplete. The benefits of the fossil record. Through radioactive isotope decay, it is possible to determine the age of rock. Sedimentary rock, when formed, acts as a timeline. Throughout the various geological strata, sedimentary rock can be used to date the contents of that strata. Being able to date the surrounding area allows scientists to estimate the probable age of the fossils found in certain rock layers. 2. In conjunction with radioisotope dating, fossils can be used to track the diversification of life. Current species can be analyzed and their ancestors determined based on their similarity to known fossils. If a chain of fossils exists, the lineage of a species can be traced all the way back to its single-celled ancestors. Fossil verification. Certain assumptions can be verified about fossils. 1. The most recent fossil should resemble the species currently living in an area. 2. If enough fossils are found, all species can be traced back to a single ancestor. 3. Based on the fossil record, inferences about the existence of novel fossil species or missing links between other fossil species can be made. They can also, and some have in the past, be verified. Missing links that are theorized can be verified when examples are found in nature. How the message in the rocks supports evolution. As I alluded to earlier, and based on the evolutionary theory, for every two species, however different, there was once a single species that was the ancestor of both. The verification of this claim is the entire purpose of using fossils in evolution. Their utilization allows scientists to trace the evolution and development of traits, species, and whole phyla. The missing links. Because of the incompleteness of the fossil records, missing links have existed in the past between whole lineages of species, and some still do. The first of these examples is Tiktaalik. There he is bridging the gap between fish and amphibians. Tiktaalik will be the first in a string of examples that showcase their respective transitional traits. Tiktaalik is a fish with limbs adapted to maneuver outside and inside water. Like amphibians, Tiktaalik has a flat head and a true neck, which is indicative of a life adapted to living in shallow water near the surface. This is Archaeopteryx, the species that suggests birds evolved from dinosaurs. This species has characteristics of both reptiles and birds. It has a jaw with teeth, wings, evidence of feathers, and an opposable big toe. Whales. The ancestry of whales is, unsurprisingly, very well documented. Whales live in the ocean and thus have a very high likelihood of dying near a body of water, which is important for fossilization. The progression of whale evolution can be seen in great detail throughout the fossil record. Coyne cites several species along the whale lineage. For example, Pakitus, which was an early ancestor that had teeth similar to present-day whales. Rhodicus, another link in the whale chain, had a strong backbone which aided in swimming, and a nose that was closer to the back of its head, resembling a blowhole. The final ancestor takes a turn towards the aquatic with Dorduon, a fully aquatic whale ancestor. And that's everything. As we can see, there truly is a message in the rock. Fossils are the language of the rocks. That's right, a common ancestor. All life on Earth can trace its lineage to a single ancestor. If we go back far enough, the relationship between fossils can be summed up in one word: evolution.